Alright. So what is the magnetic field strength going through a loop of wire of radius R? It's equal to the line integral of the magnetic permeability times the current going through the wire divided by 4 pi r squared.
Wait, is this IPC?
Oh wait, this is physics, my bad. We're doing solubility in this.
What do you mean?
You mean y'all have, we didn't cover this in IPC? Where the magnetic field strength of the magnet from running electricity through a loop? That's real physics, that's what we're doing now. Alright, solubility.
There we go.
I have some tea, and I'm putting in a sugar cube. Making sweet tea. What is the solute?
It's the water. Just kidding. I don't know. Well, one of the sugars, but in order to make tea, it's put a tea back.
It's the sugar.
But in order to make tea, put a little tea in it.
What is the solvent?
Tea.
The tea.
The glass.
What is the solution?
Sweet tea.
Sweet tea.
Wet tea.
Yes, it is. It was. Making sure y'all can spell sweet versus sweat.
I don't know how to spell it.
So the solute is what is going to be dissolved in the solvent. So solute is what you are putting into the liquid to be dissolved. The solvent is the liquid doing the dissolving. And the solution is the mixture of the solute and solvent, i.e. the final result, after they are mixed.
Are you going to include watching this mixture?
No. So this is the solute. This is the tea. This is the solvent. And the solution is after you've combined them, after you've already mixed them together.
Can you get the last bottle on that thing? Okay. Wait a second,
So what are the units for solubility?
I know. Oh, grams. The G thing. Milliliters.
It is grams solute per grams solvent. So in this case, you would put it as grams sugar per grams tea. Usually our solvent is always water. So it's a ratio of what you're putting into it and whatever it is that's doing the dissolving. Note, it is not grams sugar per gram sweet tea. It's not per solution, it's per solvent. So what is solubility?
The ability to dissolve in a solid.
Mm-hmm. If you look at it from an English point of view, that's what the word means. But from a scientific point of view, it means something else. It's actually the amount.
So I was right the mouth.
Yes. It's the amount of solute that a solvent can hold. So it's the maximum amount of solute that can typically be dissolved in a solvent. And I'd like to remember the difference between solute and solvent. So you pronounce solvent as solvent. And usually in my mind, I think of it as dissolve. So I think whenever I see solvent, I think of dissolvent. It's the thing that does the dissolving. What does it mean to be saturated?
It had the max amount of grains of this solubility.
Exactly. Means it's at its solubility limit. It's at the maximum that can be dissolved. What does it mean to be unsaturated? So below the maximum. Also means can still dissolve more. And what about supersaturated?
It's dissolved in more solute than its maximum.
It's over the theoretical limit. So let's say I have a bottle of water and I pour it into a glass and then I put 3 pounds of sugar into it. So a 3-pound bag of sugar into 500 milliliters of water. What is it going to do? Is it going to be supersaturated, unsaturated, or saturated?
Probably super thick. It's going to be super saturated.
It's going to be saturated. What's going to happen is we're going to have a giant big pound of sugar with, it doesn't matter, that's way too much, with a little bit of water on top of it. My point is, just because you add more than solubility doesn't make it supersaturated. So how do you make something supersaturated?
Well, you keep putting stuff in.
Is achieved by getting a saturated or unsaturated solution and slowly cooling the temperature down so that it is below the saturation limit. The key word here is slowly cooling. So what would happen if I put more, so if I boil some water, so I take some boiling hot water and saturate it with sugar and then put it in the freezer. Do you think that it will be super saturated?
No, because it's got a full slope.
So it would turn out to be like the green thing over there. All the sugar would immediately fall to the bottom. It was too quick. What makes sugar so easy to make super saturated solutions is actually because of how thick the mixture is. It's a syrup. And the sugar doesn't have time to quickly move out of the way. But if you put it in the freezer, it definitely will be too quick and will mess up. So if you put it into a freezer, it's going to clump at the bottom. And what do we call the stuff at the bottom?
Nice.
Precipitate.
Oh, it didn't.
The solute that has fallen out of solution. Lift your head up, Michael. So it's whatever falls to the bottom. It's also in a reaction is any solid that's made. So any solid that's made in a solution. I'm not going to test over supernate, but technically supernate is anything above it. It's the saturated solution that's above it. So looking at the green, the thing above it has to be saturated, while what's on the bottom is the precipitate. And the orange and blue ones are still super saturated. A suspension is what would happen if I shook it up and it dispersed. Remember we talked about flour yesterday? Flour, a lot of y'all said it dissolves in water. It doesn't actually dissolve. If you put flour in water and shake it up, you can get it to randomly disperse through it, and it's called a suspension. But after a long period of time, all that flour is either going to float to the top or sink to the bottom. So if you just leave a flour mixture, it will separate back into water. Same thing with oil or salad dressing. So salad dressing is a mixture of fat and oils with water. And if you shake it up, it looks all mixed up. It looks like a solution. But given enough time of not using it, it will separate out and keep your mask on. Here's another precipitate. These two clear liquids will react together to make lead or sulfur or something. Yes? Be quick. What is the correct word to say something is soluble in something else? If something is soluble in water, you would say it's what?
It's soluble.
What's the other word we learned yesterday?
That mimic thing?
Miscible. Miscible means able to dissolve into. While immiscible means unable to dissolve into. So if you have a negative side and a positive side on a molecule, it's called a what type of molecule?
Negative.
John, take your hoodie off and lift your head. Polar. It's called a polar molecule. Is water polar or nonpolar?
Polar. Lava is not polar.
Water has an oxygen side that's negative and a hydrogen side that's positive. Thus, it is polar molecule. What can water dissolve?
Anything that's polar.
So, water, being polar, can dissolve most other polar molecules. Water is actually called the universal solvent. Most things can dissolve in water. That is because it's only slightly polar, I think, is one of the things. This is generally a trend. It's not a statement of fact. It's most polar things dissolve most other polar things. Most non-polar dissolve most non-polar.
Right. There's a way you could.
Yeah, there's exceptions to it. If you're in my other chemistry class, you would know that I give you a fact, and all we have to do is learn all the 20,000 exceptions.
Holy.
It's just like in English. I before E, except after C. When is that actually true?
In other words, except for weird.
Most words break that rule. So that's a common rule, but most words break it. It's just that the common ones we deal with follow it. And so it's better to learn this for the common cases and learn exceptions down the road. So, what does stirring do?
Makes it dissolve. Faster.
That's the keyword, faster. It speeds up the rate at which it dissolves.
So I could put like a glass of water on a hot plate and just pour sugar in it, and eventually it'll dissolve, but it's a stir it makes faster.
Mm-hmm.
Alright. What is it called?
Not amount. So it doesn't change how much will dissolve, only the rate at which it does. So if you have some sugar water, some cold tea. First of all, you're not going to get as much sugar to dissolve in it. But then you put some sugar into it. 1 cube. It could be a few hours for that cube to actually fully dissolve. And if you're at a restaurant, chances are, what's the point? There's no point in waiting for it to dissolve, and it's probably never going to do it before you have to leave. However, if you stir it up for a while, you can force it to dissolve in a few minutes versus several hours. What's something else we can do to speed it up? Heat it up. So higher temperatures means the molecules are moving quite faster. Yeah. Be back quick. And those are going to vibrate and knock each other. What's one more technique we can do?
Here.
That needs to be stuff.
Okay.
Shake it.
Which will dissolve faster? A giant block of sugar, or it polymerized and grinded up? So decreasing the size of the particles will speed it up. Because think about it. If I put this cube, part of the sugar is going to have to eventually move over here. Some parts of it's going to have to move over here. We're trying to distribute the sugar cube everywhere throughout the liquid. But if we have little tiny particles, it's much easier for it to spread out. That's why when I was heating it up, I had that magnetic stirring thing. So it would, so we didn't sit there for hours. Even though I was using high temperature, having stirring helped a lot. Also, when we put in that last cup, and it was a giant big clump at the bottom, and the stirring wasn't actually doing anything, I had to go in and break it up using the glass rod. Yes. Once John gets back. There will be several questions asking how much can you dissolve blah and X grams of water. If X is 100, you just read the number. If X is 50 grams, what do you do to the number? Half it. If it's 200 grams, then you double it. And if it's some odd number, then you do cross multiplication. So if the solubility was 50 per 150, well, you could recognize that you can multiply by 1.5. Or let's say if I'm asking what is the solubility. So you saturate 50 grams into 150 grams of water. What is the solubility? Remember, solubility always uses 100 grams. So we have the ratio of 50 grams to 150 grams, and we're trying to solve for it per 100 grams. So cross multiplying, That'd be 50 times 100 is equal to 150 times x. This is being multiplied on this side, so we need to move it over here by dividing. And x would be, and lift up your head, 33.3 grams per 100 grams of water. There will be several questions asking if I put 40 grams, or if I dissolve, keyword dissolve, 40 grams into this. Is it saturated, unsaturated, or supersaturated? Well, if the solubility is this, and this is assuming 100 grams of water, then this would be supersaturated. It's going to be very similar to the Kahoot also. So everything we did yesterday is going to be very similar. Any questions? There will be a few questions asking if I have a saturated solution at 10 degrees Celsius and increase the temperature to 90 degrees Celsius, how much more can I add? Can I get to dissolve? So if it looks like this, so at 10, it's 5 grams per 100. And increase it to 90. And it's at 55 grams here. And assuming if I have a saturated solution using 50 grams of water, well, I know that for 100, how many more can I add? So for 100 grams, I can add 50 more grams. Per 100 grams. And for 50 grams, I need to divide these numbers by 2. Which means I'd need to add 25 more grams to saturate it. So a few questions like that.
Heard the homework?
Mm-mm.
Decent.
Kind of see what I made on that.
Sit up, muffin. Yeah. I'm stacked. I'm sitting.
A lot of people still haven't turned in the homework, and tomorrow's the last day.
Look at it, Mom.
Uh,
I won't take it. I just want to see what I made.
I haven't graded it because I don't like to stop grading something or finish grading something, and then someone gives it to me again, and I need to relook and see how I graded everything. Keep your mask on correctly.
Well, I just want to know as soon as I can what I made in here because I'm trying to.
You should be passing. Did you correct your test?
What's that?
All the tests we had.
I know. No, I might want to do that today at lunch. Yeah, might do that. What test? Oh, the one about the like the history of.
Yeah, the history and then a nuclear test.
All right, I'll do that during lunch too.
Should be me.
Get a reminder. Remind me. Come on, keep it. What did he do?
That's it for the review.